Pleasant day to everyone. Today we are going to discuss Module 2 of the subject CE 4111. So in this lecture, we are going to discuss horizontal alignment. So to begin with, we define highway alignment. When we say highway alignment, this is also another term for alignment route. So the alignment of route would basically be the position of the center line of the highway along the ground, and it is used to guide the path of the road through right alignment, which will be economical and easy to construct. There are two types of alignment for roads or highways. The first one is the horizontal alignment, which is simply the plan view of the road, so how we see it on top view. So it would now be a combination of straight lines or your tangent lines in your curves. And then we also have our vertical alignment, which would include now our vertical curves. So in vertical alignment, this will now include or take into consideration the profile of our root. So in this lecture, we'll be focusing on horizontal alignment. So for highway alignment, this is now a three-dimensional case or measure of our highways. So it's a combination of so when we put it together, we'll have now our horizontal and our vertical alignment plus the cross section of our road. The cross section is how we see it here. Dito, yung ating super elevation. And then your horizontal alignment, how we see it on top. And then our vertical alignment is how we see it on the side, how it goes up and goes down. So for horizontal alignment, this is now defined as the definition or description of the location and orientation of our highway in plan view through our horizontal curves. So this would now consist of a series of straights or our tangents, our circular curves, which would include our simple, compound, and reverse curves, and our transition curves or our spirals. So also, we could add in our horizontal alignment what we call the back tangents. So the basic elements for horizontal curves now would be defined by the radius of curvature and the super elevation rate, as we have discussed in the geometric design or geometric requirements of road design. So a proper design of the horizontal alignment would now result in high performance regarding the speed of vehicles or the design speed, the safety of travel, efficiency or ease of movement, comfort, and lastly, we have economy and an increased capacity. So in horizontal curves, as we have said, we would now take into consideration our circular curves. So as a review from our surveys, specifically engineering surveys, we have your three different curves. The first one is the simple curve, which is now consisting of a single curve. We have our compound curve, which is composed of two curves with two different lengths of radii. And we have your reverse curve, which would also be consisting of two curves, but would be facing different or opposite directions. Now, for horizontal alignment, we could apply this both for the design of railroads and highways. For railroads, we follow that the design of horizontal alignment will assume that the arc distance is the same or is equal to that of our chord distance. And for highways, it follows that the arc length or the arc distance will be the considering factor in our designs. This being said, we could now say that for railroad design or the horizontal alignments of railroad, it follows the arc definition, and for highways, it will follow the chord definition. For arc definition, from the term itself, we are referring now or going to solve for the degree of curvature in terms of our arc. So let's take into consideration this simple curve. So we have here your radius. So considering now an arc which is 100 feet or almost 20 meters in length, and we have here your, so for a 100 feet or 20-meter arc, it will have a corresponding value of D. Okay? So with that, we compare now the ratio of D and 360 degrees, which is the angle for a whole circle. So we equate it to the ratio for the corresponding lengths of the arc. So for D, we have 100. 360 is for the circumference of the circle or the total length of a circle, or in metric, that's 20 meters over C. So C, as we know, is 2 pi r, or we can now get the relationship between the degree of curve and your radius of curvature. So the degree of curvature now is equal to 1145.916 all over r. So this is taken from 360 and 2 pi. So you can memorize this equation, or you could simply derive it from this one. Okay, so if the degree of curvature is known, then you can find for the radius, or if the radius is known, then you can solve for the degree of curvature. Okay, so next we have your chord definition. For the chord definition, we are now going to define the degree of curvature. Instead of the arc, we are going to use now the length of the chord. So let's say we have a length of chord which is at 100 feet or 20 meters. So this length now of chord will also have an equivalent degree of curvature. So in order to solve now for the degree of curvature in terms of our radius, we now consider this triangle. So this angle now is equal to D over 2. So from the right triangle, we have here half of LC. So this is 10. This is the radius. And this is your angle. So from right triangles, we have a sine. So sine of D over 2 is equal to 50 feet over R, or in metric, that's 10 meters over R. Or simplifying now, we have the radius is equal to 10 divided by sine of D over 2. So again, you can memorize this equation, or you could simply derive it from the triangle. Okay, so for arc definition, it's 1145.916 all over R, and for chord definition, that is sine D over 2 equal to 10 divided by R. So this is for metric. Okay, if you're going to use feet, just substitute the values in our equations. So since our horizontal alignment from our computations can be defined by the radius of curvature and the degree, from this we could also define the sharpness of your horizontal curves. So from the radius, if we have a short or small radius, it means our curve is a sharp curve. And when it is a sharp curve, it would now result to a risky and dangerous curve, meaning it's very hard to maneuver through these types of curve. And when we have a small degree of curvature, it means that we have a flatter curve on our design. So therefore, from these conceptions, we could say that the radius of curvature is inversely proportional to the sharpness, and that the degree of curve is directly proportional to the sharpness of the curve. And from our formula or our arc definition and chord definition, we could simply see that the relationship between our radius and degree of curve is inversely proportional. So the higher the radius, meaning we have a lower degree of curvature and a flatter curve or a lower sharpness, and vice versa. So because of the sharpness of curve or of our horizontal curve, we would now need a provision of an adequate safe stopping sight distance or any change in or transition in the alignment or in the direction of the road. So since we are applying simple curves in our design of horizontal alignment, let us just have a rundown of the equations we use for simple curves. So we have for your tangent distances, T. So we have here your tangent distances, T. That is now computed as R tangent of central angle divided by 2. Okay. Then we have our chord distance, LC. This one, chord distance, LC, is computed as twice your radius sine of delta over 2. We have the length of your curve, L. So that's solved as L over delta equal to 2 pi r divided by 360. Or we could also solve this as L over 20 is equal to delta over D. Okay? So whichever is given. So if radius is given, then we use the first equation. If the degree of curvature is given, then we use the second equation. Next, we have for your middle ordinate M. This one is defined as R times 1 minus cosine delta over 2. Then we have your external distance, which is your E equal to tangent theta over 4, or that's equal to R times 1 minus 1 over cosine delta over 2 minus 1. But basically, for our horizontal alignment, what we will be needing is this distance, your middle ordinate. Okay? So to understand now horizontal alignment, let's have an example. So this is also an application of your horizontal alignment with regards to our stopping sight distance. So example 1, bushes grow near a two-lane highway, circular curve with radius 160 meters, measured from the center line of the highway. The minimum stopping sight distance is 150 meters, and the total width of the pavement is 7. How near from the edge of the pavement can the bushes be allowed to grow? So what we have here is from the given. So we have here our highway with total carriage way width or pavement width of 7 meters. So for each lane, that will now be 3.5 meters. Okay. So our critical lane will be this inside lane. Ang ko-consider kong SSD will be at the center of our critical lane. Itong line na to. So, ang hanapin natin will be this distance M. So, ibig sabihin, at this portion, it should be clear or unobstructed so that when a vehicle will be at this point, it will be able to see now another vehicle going to this direction. Okay. So, if we will not clear this area, we could now expect an accident. Kasi hindi makikita nung vehicle at this point yung paparating. Baka bigla siyang mag-overtake kung mayroong isa pang sasakyan dito. So, hindi niya ma-expect na meron pala siyang kasulubong. So, that's one probable cause of accidents. That's why we need to consider now our sight distance when it comes to horizontal curves. Okay? So for our solution, so we have here the center line of our highway. The critical inside lane will be what we will consider. So we have here our SSD, stopping sight distance. The obstruction should be until or limited until this horizontal line. So we have your radius, minimum radius of curvature, and this will be our radius for our horizontal alignment, RV. Okay, so now consider this area only. For our solution, we could solve now for RV simply as the difference between our R mean and 1/2 of the lane width. And the lane width is 3.5 meters. So from here, we now have RV is equal to 158.25 meters. So ito yung gagamitin nating value for our equations. Okay? So we have now your SSD, 150. The radius of our critical curve will be RV. From here, we can solve now for our SSD, which is now equal to the length of the curve. And we know that the length of the curve is equal to delta RV. So given SSD, given RV, so we can solve now for our delta or central angle. And that is equal now to 54.31 degrees. So take note, you have to convert it to degrees. Kasi pag unitless yan, it means that the angle you have solved is in radians. Okay? So next, once we have solved for your central angle, we can now solve for the value of this red distance. Okay, so the distance from the center to this limit. And this limit now is simply equal to, by triangle, so this h is equal to cosine of h over your hypotenuse RV. So we'll have now h is equal to 140.81. So since we know our radius, you know already our h, we can now solve for our m. And m now is equal to RV minus h, and it will give us a value of 17.44 meters. Okay? So this is not yet our final answer. This is just the value of our middle coordinate for our critical curve. Okay? So aside from this, we could also use our derived equation, the equation that I have given you a while ago for middle ordinate, or combining now the central angle equation and or your length of curve equation in this one, we can now solve. We could also have a derived equation which is m is equal to RV 1 minus cosine SSD divided by RV. Okay. So any will do. It will still give us a value of 17.44 meters. So next, after solving now your MS, so we were able to solve a while ago. H is equal to 140. MS now is equal to 17.44. So we take into consideration this section. So we have 1/2 of the lane width is, or one lane is 3.5 meters. So given now this value, M, which is 17.44, this distance is our 1/2 length of, or width of the lane. So what we are going to consider will be this shaded area, this yellow shaded area. So dito lang. Kasi dadaanan pa ito ng sasakyan. So ito lang yung consider. So from the figure, the obstruction distance now from the edge of the pavement, is equal now to m minus 1/2 of your lane. That is equal now to 15.69 meters. So ito yung hinahanap natin. Gaano kalayo dapat yung mga bushes from the edge of the road. Meaning, side obstructions now here must be cleared in order to allow drivers in our critical lane to see the hazards and therefore apply an SSD to avoid collisions along our curves. Okay? So we have here scenario 1. Do we need to clear these obstructions? So this is a curve. So kung andito ka, kunwari walang traffic, andito ka, hindi ko makikita dun sa side na to. Hindi ko alam kung may parating nasasakyan doon. So next. Scenario 2, we need to clear this obstruction. This is along Otohan. Yung road natin, Upper Bonifacio. Ito yung curve natin. Do we need to clear this distance? So we need to clear it because the students, di ba may crossing dito sa side na to? Students crossing at our gate 4 will be at risk because vehicles coming here will not be able to see our crossing students or crossing pedestrians. So dapat medyo may distance, safe distance na clear dito. So dapat wala yung ibang portion ng building na to. Then, we have scenario, do we need to clear the obstructions? So ditong corner, yes, okay na, okay lang kasi nakikita ng sasakyan. Galing dito yung sasakyan na paparating. Pero ditong side, medyo alanganin kasi hindi nakikita ng masasakyan na galing dito yung sasakyan sa side nito. Okay? So there will be possible angle collisions due to obstructions of buildings. So if you do not want to do this, then you have to make this as an signalized intersection so that they will be able to stop. Maglagay ka ng sign na you have to slow down because they are approaching an busy intersection. Okay? So that's it for horizontal alignment, for circular curves, specifically simple curves. So for our references, you can check these notes or this site. So thank you for listening.